Scene script. Dive right into the core of networking with the importance of Source NAT and NTP. Let's start by understanding the role of Source Network Address Translation, or Source NAT. This technology is a cornerstone of internet communication. It's like the doorman of a large apartment complex, managing and directing the traffic of information packets between the private network and the internet. But what makes it so important? Well, imagine a world where every device connected to the internet needed its own public IP address. With the ever-growing number of devices, we would quickly run out of addresses. This is where Source NAT steps in. It allows multiple devices in a private network to share a single or a pool of public IP addresses, effectively conserving the limited public IP address space. Plus, it adds an extra layer of security by hiding the private IP addresses from the public internet, making it harder for malicious actors to target specific devices. Now let's switch gears and talk about Network Time Protocol, or NTP. This might not sound as exciting as Source NAT, but believe me, it's just as critical in a network infrastructure. Think of NTP as the grand timekeeper of your network, ensuring all your devices are operating in the same time frame. Why is this important, you ask? Well, accurate timekeeping is crucial for many network operations. For instance, it helps in maintaining the integrity of timestamped logs, which are vital for network troubleshooting and security audits. Without NTP, figuring out the sequence of events during an incident can become an arduous task, akin to solving a puzzle without the picture on the box. Moreover, many network protocols and applications, like Kerberos for authentication or digital certificates for secure communication, rely on accurate time synchronization. So without NTP, these fundamental network operations could be compromised. Understanding the importance of Source NAT and NTP in networking is the first step in mastering their configuration and verification. And that's exactly what we're going to delve into next. So stay tuned for an enriching journey into the world of networking. Now, you will learn how to configure inside Source NAT. Let's dive right into the step-by-step process of configuring inside Source NAT using static IP addresses and pools. Start by understanding that inside Source NAT is a technique that allows private networks to connect to public networks. It does this by translating the private IP addresses of internal devices into a public IP address that's routable on the internet. Step 1. Define your pool of public IP addresses. Use the IP NAT pool command followed by your pool name, start IP, end IP, and netmask. This creates a pool of public IP addresses that your internal devices can use when they need to access the internet. Next, you'll need to create an access list. This list defines which internal IP addresses are allowed to use the NAT pool. Use the access list command followed by the list number, permit, and then the range of your internal IP addresses. Then it's time to bind the access list and the NAT pool together. Use the IP NAT inside source list command, followed by your access list number and pool, and then your pool name. This tells the router which internal IP addresses can use which pool of public IP addresses. Now, let's move on to configuring inside Source NAT using a static IP. This is where a single internal IP address is mapped to a single external IP address. The first step here is to define your internal and external IP addresses. Use the IP NAT inside source static command followed by your internal IP and then your external IP. The next step is to designate your inside and outside interfaces. Use the interface command followed by the name of your internal interface. Once you're in the interface configuration mode, use the IP NAT inside command. Repeat this for your external interface, but use the IP NAT outside command. Both these processes, whether using a pool or a static IP, are fundamental to the smooth operation of your network. They allow your internal devices to communicate with the outside world while maintaining the security and integrity of your network. And there you have it. You've just configured inside Source NAT on your network. Remember, practice makes perfect. The more you practice these steps, the more intuitive they will become. Before we wrap up, it's important to note that inside source NAT is just one type of NAT. There are also outside source NAT and destination NAT, each serving its unique purpose in networking. But that's a topic for another day. With these steps, configuring inside source NAT becomes a walk in the park. So keep practicing, keep configuring, and soon you'll be a pro at handling all things NAT. After configuration, verification is paramount. Here's how to verify inside source NAT. Now that we've successfully configured inside source NAT, it's essential to verify that everything is working as expected. Let's dive into the process. First and foremost, you need to access the router's command line interface. Once you're there, run the Show IP NAT Translations command. This command will display the current NAT translations table, which should include the inside source addresses you've previously configured. Look out for the inside global and inside local columns. The inside global column should display the public IP addresses assigned by NAT, while the inside local column should show the original private IP addresses of the devices. If these align with your configuration, that's a good sign. Next, you want to ensure that the NAT statistics are in order. Running the Show IP NAT Statistics command will give you a summary of the NAT configuration and operation. Check the total active translations field. It should match the number of translations you've set up. Also, pay attention to the hits and misses fields. A hit means that a packet matched an existing entry in the NAT table, while a miss signifies that no match was found, creating a new entry. A high number of misses could suggest a problem with your configuration, so keep an eye on this. To further confirm the inside source NAT operation, you can use a device on the network to access an external resource. If the connection is successful and the device's private IP address is translated to the public IP as configured, then your inside source NAT is functioning correctly. Finally, remember, troubleshooting is an integral part of the verification process. If you encounter any issues, review your configuration. Check your network's connectivity and ensure your NAT rules are appropriate for your network design. Verification ensures your inside source NAT configuration is up and running as it should. After all, the ultimate goal is to ensure seamless network communication, and verification is a critical step in achieving that. Next up, we delve into the configuration and verification of NTP. Network Time Protocol, or NTP, is a crucial part of any network. It ensures that all devices on the network are in sync with the same time. This is essential for logs, security protocols, and other time-sensitive operations. But how do we configure it? Let's dive in. First, we need to configure NTP in server mode. To do this, we use the command NTP master. This command will set the device as an NTP server, allowing other devices to sync their time with it. However, remember to specify the stratum level with this command. The stratum level is a measure of the distance from the original time source, with lower numbers being closer. So a stratum 1 server is directly linked to an atomic clock, while a stratum 2 server is linked to a stratum 1 server. Once we've set the device as an NTP server, we need to configure NTP in client mode on the other devices. This is done with the NTP server command, followed by the IP address of the NTP server. This command tells the device to sync its time with the specified server. Now that we've configured NTP, we need to verify it. Verification is done using the Show NTP Status and Show NTP Associations commands. The Show NTP Status command displays the status of NTP on the device, including the stratum level and the reference clock. The Show NTP Associations command shows the NTP servers the device is associated with. In server mode, you should see the device's own IP address as the reference clock, and in client mode, you should see the server's IP address. If you don't see these, then there might be an issue with the configuration. NTP configuration and verification is just as straightforward once you get the hang of it. So keep practicing, keep configuring, and soon you'll be an NTP wizard, able to sync and verify time across any network. To wrap it up, here are the key points from today's session. We delved into the importance of Source Network Address Translation, or Source NAT, and Network Time Protocol, simply known as NTP. Both are crucial in the realm of networking. Source NAT optimizes IP address utilization and enhances security. On the other hand, NTP ensures time synchronization across all devices on a network, which is essential for accurate logging and troubleshooting. We walked through the configuration and verification of inside Source NAT using both static and pools. This process allows for efficient routing and connectivity in your network. We also explored how to configure NTP in both client and server modes, ensuring your network devices are all on the same temporal page. And that's a wrap. With these skills, you are now better equipped to manage and troubleshoot network configurations involving Source NAT and NTP.